I'm going to quickly just go through the new registration system and the old because it's important. This was implemented for May last year for the engineer, and it's slowly evolving for the technician and technologist. In fact, the technician and technologist forms now almost totally to the new system. They've done it every couple of months. The new policy guidelines are competency based, not like the old one, which was more training based. What training did you have? How did you get the right training? The new one is, can you do? Can you plan? Can you design? Can you do this? And we're going to electronic system. We were hoping from late 2014, but as you know, with all computer systems, there are delays. And it looks like now later this year, but we still don't know yet. And lastly, all the documents are available on the ECSA web. You can pick them all up. The new system will run in parallel with the old system for at least 2 years. And those who are training in the old system can finish, and we're expecting the current system, the old legacy system, to be phased out from March 2016. After that, everybody will have to be on the new system. Up to then, you can take your pick, one or the other. The present system, there are various different things. For example, the civil guys have got to write 2 essays. The electrical guys have got to hand in forms 87, 88, which is a claim to competency. The mechanicals require a full design report and various things like this. I'm talking to the engineers here. The technologists are not that different. And lastly, as I said, they'll be phased out. And that's important. From April 2016, it must be on the new system. As I mentioned, they can go on both. Right. The new guidelines documents the most important change. There's no change in standard. Standard remains the same. The change is in the assessment. And secondly, where policy and rules and regulations were all split, we've now split it. There's a policy document, and you'll notice it's P, which means it applies to all categories. We have competency standard, PE for the engineer, PT for the technologist, PN for the technician. I'm not listing them here, I've just listed the one. Then we've got an O3, which is processing. How is the application processed? So that you people know what's being done. And there's a training and mentoring guide. It's a guideline to help people to make sure they get the right training, more so in industry, but it applies equally here. And then there's a guide to the competency standard. Now, both those two documents, the 3, 4, and 8, actually point out the various competencies and how you can assess those competencies and how you can prove that you are meeting those competencies. Then there's a RO5, which is a discipline-specific training guideline. It's a guideline, it's not a policy, and it says how in the civil environment can you get the right training, or how in the electrical environment, or how in the mechanical environment do you can get the training. And lastly, there's E17P, which is for the foreign guys, or the non-accredited degrees in South Africa. And we'll cover all those. Any questions quickly? Let's carry on to important stuff. Sorry?
I know you mentioned the mentor thing earlier, and if you've done, for example, all the necessary scope of work according to the requirements, but you haven't had a mentor throughout the period.
It's not important.
Okay, because I had one while I was in industry.
That's fine. The most important part of the mentor, he's there to help you go through the document and make sure that it's right. That to me is the most important part of it. If he goes and he says, hang on, I'm mentoring a number of guys. I got one of the guys formed last week. Brilliant. He says what he does, but nowhere does he say he's done any implementation. So I went back to, oh yes, he did the construction as well, but he didn't say it. So I said, well, tell us about it. You know, that's the type of thing that the mentor can do for you.
So it doesn't have to be a formal mentor in essence, just someone
No.
who's maybe...
Under the commitment and undertaking, they undertake to provide a formal mentor. And we are finding that formal mentorship does work if it's done properly. And I can name companies here. When I get an application form from certain companies signed by the official mentors, I can almost blindly sign it. I don't, I still go through it, but I know from that company, with this mentor, that guy's done everything. And that's the big advantage of the mentor. Right, 2 principles. Again, when setting up a training program, first is the variety of work. It's no good only doing planning, or it's no good only doing investigation. You've got to try and go through as much as you can of the life cycle of the product, of the design, the development, the planning, the commissioning, the maintenance of it, and then the deactivation or decommissioning when it gets it. Do as many of those as possible. The variety can be tailored at various stages in the planning life cycle, as long as you make sure you've got variety. And the specific functions, commissioning, testing, troubleshooting. So you can get, we expect some experience in several of those stages. Not all of them, it's impossible in 3 years to get all, but a good variety of them. Secondly, increasing responsibility. And here in an academic environment, it's very easy to show that, and we'll talk about it just now. We want to see that responsibility and accountability growing, so that they eventually, after their 3 years or what, they are effectively operating at the same level as you would expect a professional to do that. Right, what are the competencies? You'll notice that under the new thing there are only 3 hard engineering competencies. Analyze engineering problems, synthesize solutions, and using your contextual knowledge to develop solutions to it. Those are known as the A, or the and the outcome group, and the CEP is complex engineering for the engineer, broadly defined for the technologist, and well defined for the technician. You get the next series of them, which are communicating and managing. Communicating, if you guys can't communicate to your students, you're not going to win. Same thing in industry. If you can't communicate your design that you want to put in or what you want to do to the finance guys, you're never going to be able to get in. So communication is one of the most important things that industry keeps shouting about students. They get graduates and they can't communicate, or they can't manage. Again, you'll notice it's manage engineering activities. It's not project management. We expect some knowledge of project management, but if you're only just doing project management, forget it. Because all you're doing is managing other people. When you're doing an engineering project, you're managing people doing engineering, and you're doing engineering itself, and not just managing people. Then there's the other group of the address impacts of people and the environment and meet regulatory environments. Again, these are the ones we talked about, the contracts and finance and that type of stuff, and the environment and health and safety. And then the others are the acting ethically, exercising judgment and being responsible. That's your degree of responsibility. And last but not least, lifelong learning, to keep up to date. And those are the so-called exit level outcomes, or what we call competency level outcomes. And that's what we expect an applicant to be able to demonstrate those 11. And we'll come to them, it's very easy. Those of you who've done accreditation visits, you know you've got 10 that you've got to demonstrate that the students can do. We've just added one extra in here, and that's the lifelong learning. And the whole lot together are called complex activities. Right. Sorry?
Yes, the complexity of the situation.
Yes.
The measure of how complex it is.
I'll come to that now. Oh, this thing doesn't want to go back. Okay, we'll carry on. Right. Let's go back to the, sorry?
Is there in terms of professional degrees, is there a hierarchy between the professional engineer and the professional technologist? Which one is higher, or it's the same?
No, they're different. I'll come to that. That's what I mentioned. The engineer we call complex problems. The technologist is broadly defined problems. And the technician is well-defined problems. And I'll explain I'll give you a slide on the differences, quite easy. Just to go through, just to prove that there's no change in standard. In the old system, it was problem identification. Again, it's the investigation, analysis, synthesis. It's problem and formulation. It's finding and selecting information. It's evaluating, investigating, testing and research. And it's analysis of the factors that influence. And then it's problem solution. So you'll see there's no difference in the new system to the old system. The difference is in how you express it. Execution, again, implementation. But you'll notice if you go back to that one, the execution, it says the work must be aimed at. In other words, it's more input based and it's more training based than the new system, which says demonstrate you can do it. Give me an example. Responsibility, exactly the same. If you look at the new system, there it is, engineering problem solving, define, investigate, design, comprehend. No difference. And you'll see it's the technician, the technologist and the engineer. Right, now let's go to the engineer. Complex problem. First of all, it requires fundamental in-depth knowledge. You cannot solve that problem without having to go back to your fundamentals and your principles. So you need, for the engineer to demonstrate a problem that you've solved where you've had to use your fundamentals, the maths and the basic sciences and the basic engineering to be able to solve it. That's the first requirement. The second requirement, it must be one of the following or more. Ill-posed, underposed, overspecified. High-level problem including components and totally unfamiliar or infrequently accounted. So it's something new. Something you've never done before. I'll never forget my final year varsity exam. One exam paper, there wasn't a single question I'd seen before. There wasn't a single question that came out of any of our notes or any of our textbooks. All they were trying to do is, could you solve a problem? I walked out there thinking I'd failed everything, but I got a cum laude for it. Right, and then the next part of the solution must be one of the following. Solutions are not obvious, require originality, based on fundamentals, are outside scope and standards. Now, if you always had to work with inside scope and standards, you never get any development. How are you going to develop something new if you've got to stick to the old stuff? That's a big difference. Require information from a variety of sources and involve wide-ranging and conflicting issues. And this is one of the biggest problems that you have in industry. You often have to make a decision on 40% of the information. But this is where your judgment comes in. Is that information sufficient for you to make a decision? And then one or both of the other. Requires judgment in decision and has significant consequence and range of context. So you'll see it's A, definite, one or more of B, C, D, one or more of E to H, and one or more of the last two. And that's how you can identify, is it a complex problem? By answering those questions. Managing activities, same story. Scope, the context, the resources, the consequences. And you'll notice the wording here is slightly different again. It's complex, 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 complex all the way through. One of the most important things too is teamwork. Today in engineering, nobody works on their own outside. You work as a team. And this teamwork, that's why we push it so much at the university side. How do they work in a team? And particularly a multidisciplinary team. And then the C ones are the judgment, addressing all the impacts of engineering, meeting regulatory, ethically, sound judgment, responsible, and last is the professional development you've kept up to date. And this applies to everybody, yeah? Right. This is the most important part of the new system. It replaces all the others. You need to write an engineering report of up to 6,000 words where you defend yourself and you state how you meet those 10 exit level competency 11 competency outcomes, how you meet them and where you meet them. And you need to refer back to your summary sheets. In this particular period, I had this problem which I solved, and that meets the definition of a complex, and here's what I did. It's not a report on a specific project, it's work done on your whole environment. And for the engineer, it's really more a reflective report. For the technician and technologist, it's much more structured. They ask you specific questions to answer, whereas the engineer, we expect him to do it himself. Because again, it's replacing the civil engineer essays, it's replacing the electrical design for competency, and here you need to prove, and we need a bit more from the engineers than we need from the technician or technologist. See, it's reflective, it's not a narrative, and it's also a test of communication ability. Right. Broadly defined. Now this is the technologist. Notice, requires a coherent and detailed knowledge of defined aspects of the professional discipline with strong emphasis on the application of developed technology. So it doesn't require fundamental principles of the maths and science to the same level as your engineer does. It still requires a detailed knowledge and defined aspects, and generally it's in a sub-discipline more than in a discipline. The problem has one or more, again, concrete or ill-posed, requiring identifications within a complex, may be unfamiliar but often involve frequently encountered stuff. That's today's technology, today's doing. The solutions may be applications of well-proven analysis techniques, may be partially outside standards, but cannot deviate too much. Require information from various sources, involve a variety of factors, and requires judgment and has significant consequences. Notice the difference here between the well-defined problem and the complex problem. The other one is totally new, it's indefinite, it's got no obvious solution, that's your job to find it. Here, generally there's an obvious solution to the problem, and it can be solved with standard stuff. If you look at the broadly defined activities, very much the same as the engineer. I'm not going to waste a lot of time on it now because we'll come to it later, and you will have this. You'll notice it's very the same, as that, but it's more restricted to the context, teamwork, and usually within a sub-discipline. Right, the technician. Technician now is a well-defined problem. Notice again, requires limited theory knowledge, but normally requires extensive practical knowledge. So you don't expect that guy to have to go and use maths and science and stuff to solve things out there. It requires his practical experience he's picked up. The problems are concrete, are largely complete, but may require refinement. Discrete components may be unfamiliar, but are generally familiar. And it's by experience that you pick this up. And the solutions, again, solved by standard methods and codified best practice, are encompassed by standards and codes. Judgment of outcome is required, requires information that's concrete, involves several issues, and again you'll see requires practical judgment, and the consequences are locally important but not far-reaching. So what I'm trying to get over to you is you can see how you can now identify a complex problem, a well-defined problem, and a broadly defined problem, and you can see that range.
The University of Johannesburg. Rethink, reinvent.